Okay, hi everyone. We are first just going to do a little area between curves review. This is the last topic we covered before spring break. So let's just look at the graph of two functions. So here I've graphed f of x, which is some line, and g of x, a parabola. So to find the area between them, which is just this little shaded part, it's the area of the section between the two graphs. Okay, you're just going to set up your integral from a to b. Okay, and so a and b, these are the x values of where the two graphs intersect. So in this case, a would be 0, b would be 1. And then you're going to do, in this case, we would do f of x minus g of x. It's always the equation of the top of the shaded area minus the equation of the bottom. So if I look at this graph right here, if I look at the shaded section, I can see this line is on top, and that's the graph for f of x. And the parabola is on the bottom, which would be the equation for g of x. So that's why this one is f of x minus g of x. It's always what's on top of the shaded area minus what's on bottom. And then once you set up your integral, you're going to do the antiderivative and then just evaluate that definite integral from there. So let's go ahead and work through a few examples. So to find the area enclosed by these curves, first thing you're going to do is graph them. Okay. So usually I just graph from like x equals -2 to +2, but since we're just doing the square root here, I can't graph any negative ones. So what I would graph, what x values I would plug in, is I would plug in 0, since I can't use any negative numbers here in the square root. So I would do 0, 1. I'd probably skip over 2, since 2 is not a perfect square. And then I would probably graph x equals 4 as well. However, this one's not going to fit on the graph, so I'm probably just not going to worry about this one for now. So what I'm going to do is take 0 and 1 and plug them in to each equation and graph these two curves. And y'all are going to have to bear with me as I write on the screen. It's going to take me a while to get used to having to write on the screen of the computer. So if I plug in 0, okay, that's going to give me y equals 0, and if I plug in 1, that's going to just give me y equals 1. So for y equals x, the 2 points I'm going to graph are 0, 0, and 1, 1. And then I'm going to go ahead and draw my line through that. Okay. So that'll be the graph of y equals x, which we know is just a line. And I'm going to label this as y1, and I'm going to label this one as y2. And then I'm going to come over here and label this y1 so that I'll remember. And then I'm going to go ahead and graph this second equation, y equals the square root of x. So if I plug in 0, square root of 0 is 0, so I'll have another point at 0, 0. If I plug in 1, square root of 1 is 1, so that generated the same 2 points. So when I graph this square root curve, it's going to be curved above the line like this. So remember, a square root curve is always curved above a line. If we were graphing a parabola will always be curved below the line. And then the area that we are looking to find is this little part between the square root and the line. Okay. So first thing I'm going to do is identify A and B. That is the points where they are intersected. So this is the first intersection point. So the one on the left is always what I make A. So A is going to be 0. And then the second place they intersect is going to be my B value. So B is going to be 1. Okay, again, these are always the X values. So I'm reading these numbers off of the X axis. Then from here, I can set up my integral. So it's going to be from 0 to 1, from A to B. The smaller number is always going to be on the bottom. And then I'm going to do the equation of what's on top, which would be this one, which is y2, which is the square root curve. So that is going to be x to the 1/2 So I'm going to rewrite that square root with an exponent, so it'll be easier to do the antiderivative. Minus the equation of what's on the bottom, which is the line, which is just x. And then dx. Remember, dx just means this is the derivative, so we have to do the antiderivative. Then from here, I'm going to go ahead and evaluate the antiderivative, which is add 1 to the exponent. So I'm going to take this 1/2 and add 1, so add 2 over 2, which is going to be 3/2, and then you divide by that new exponent. So the coefficient is just going to be the reciprocal of the new exponent. So that's going to be 2/3 x to the 3/2 minus, then I have to do the antiderivative of x to the first. So the new exponent is going to be x squared. You always add 1. So the coefficient is going to be the reciprocal of that, 1/2. And then I'm going to plug in 1, and I'm going to plug in 0, and then I'm going to subtract the two numbers. So you always plug in the top number first, get that value, plug in the bottom number, get that value, and then you do whatever you got on top minus whatever you got on the bottom. So if I plug in 1 to any power is just going to be 1. So here, x to the 3/2, when I plug in 1, that's just going to give me 1. Same thing with x squared. So this is just going to end up being 2/3 minus 1/2 when I plug in 1. When I plug in 0, okay, both of these are going to be 0, so it's just going to give me 0 for the second part. So all I need to do is evaluate 2/3 minus 1/2, which is just going to be, this is going to be 4/6, this will be 3/6. So 4/6 minus 3/6 is just going to give me 1/2. And remember, this is area, so it's units squared. Okay, for this second one, we've got f of x equals x squared minus 1 and g of x equals 1 minus x squared. So for this one, what I'm going to plug in for my x's is -2 to +2. So I'm going to plug in -2, -1, 0, 1, and 2 to both of these equations. So if I plug in -2, -2 squared is 4, minus 1 is going to be 3. So I'm going to have a point at -2, 3. Then when I plug in -1, -1 squared is 1, minus 1 is 0. So I'm going to point at -1, 0. Then when I plug in 0, this will just be 0 minus 1. So when x is 0, y is going to be -1. And then when I plug in 1, I'm going to get 0 again. And when I plug in 2, I'm going to get 3 again. And then I'm just going to draw the parabola through those points. Okay. And this graph is f of x. Then I'm going to graph g of x, which is just going to be a line. So if I start with -2, 1 minus a -2, that's going to be 3. So that'll be the first point of intersection. Then 1 minus -1 is going to be 2. 1 minus 0 is going to be 1. 1 minus 1 is going to be 0. And then 1 minus 2 is going to be -1. So then my line is just going to go through those points. Okay. So this is the first intersection point. So this is my A value. And if I look here, the X value is -2. So A is going to be -2. And then here's the second place they intersect. So B, that X value right there is +1. Okay. So what we're finding on this one is this area right here. So let's go ahead and set up our integral. So A is -2, B is 1. The smaller number is always going to be on the bottom. So if I look at what's on top, okay, that's the line. Well, this is the equation of the line. So I'm going to have 1 minus x minus The parabola is on the bottom. So since there's more than one term in this equation, I'm going to have to make sure I distribute that negative. So this is going to simplify to 1 minus x squared plus 2, and then I'm going to go ahead and combine my like terms. So this is going to end up being negative x squared minus x. Sorry, I combined a few steps right here. When I distribute that negative, this is going to be plus 1, and then 1 plus 1, that is what's going to give me the plus 2. Then I'm ready to do the antiderivative. I'm going to move this over here. So then for the antiderivative, I'm going to add 1. So this new exponent's going to be 3. So the coefficient is going to be negative 1/3. So negative 1/3 x to the third minus, this is going to be 1/2 x squared, and then when you have a constant, you just tack on an x with it to do the antiderivative. Then I'm going to plug in 1, get that answer, plug in negative 2, get that number, and then subtract the 2. So when I plug in 1 to any power, so 1 cubed and 1 squared, those are just going to be 1. So this is going to work out to be negative 1/3 minus 1/2 times 1, so just minus 1/2 plus 2 times 1. Okay, I'm going to figure out what this is. So these are all going to be, the common denominator is going to be 6. So this is going to be negative 2/6 minus 3/6, which is negative 5/6. And then plus 2, which is 12/6. So negative 5/6 plus 12/6 is going to give me 7/6. Okay. Then I'm going to plug in negative 2. Okay. So negative 2 cubed, that's going to be negative 8. Okay, times negative 1/3 is going to work out to be positive 8/3 minus negative 2 squared is going to be positive 4 times 1/2. So minus 2, and then 2 times negative 2 is going to be minus 4. So I'm going to go ahead and combine these right here. So this is going to work out to be minus 6. So 8/3 minus 6 is going to be 8/3 minus 18/3, so a negative 10/3. So this is going to work out to be 7/6 from when I plugged in 1, minus, I got a negative 10/3, so this is going to switch to plus 10/3. Okay. I'm going to change this to 20/6, so 7/6 plus 20/6 is going to give me 27/6, which I can reduce that. I can divide both by 3. So that'll be 9/2 units squared.